Okay, Lamai, this is going to be a short discussion on electrolysis, right? So you find this topic in Unit 13, Electrochemistry. This is in the last half of the lesson. So in 2019 A-level paper, your first new syllabus paper, they gave a good question, good essay question from electrolysis. Okay, so I'm going to do the question with you. And before that, I'll revise you what are the basic theories you need to remember before you go to the exam on electrolysis. Okay, so I'm going to use this table for that. Okay, so electrolysis, the simple thing is, Lama, you need to remember these five examples. Okay, you can see them in the table. Sodium chloride liquid electrolysis using inert electrodes, like that. You have five examples. So what is electrolysis? So you are supplying electricity in order to do a non-spontaneous chemical reaction. Okay, so I'll explain using our first example. So let's take, we have a uh, sodium chloride liquid, or you can say molten sodium chloride solution. Now in this solution, you have liquid Na plus ions, and then you have Cl minus liquid ions. Okay, so now let's supply electricity using a power source, power supply. So now you know this is our positive electrode and this is our negative electrode. Understand? So what happens now? Electrons will start to flow from negative electrode, and electron supply will happen to our from this negative electrode to the solution. Okay, so in this solution, this we can't say it is a solution anyway, this liquid. Okay, so there are two ions, like I said. So the one with the positive charge can come closer to this negative electrode, isn't it? So to this place, what will happen? Sodium plus will come to this place. Okay, so sodium plus will come and will take that electron and become sodium metal liquid. Understood? So now what is this reaction? So this is a reduction reaction, reduction half. Okay, because electron gaining is reduction. So now you can say sodium plus has reduced. Okay, so now if it is to be a complete circuit, okay, so electron outflow should occur from this electron, isn't it? So then to release electrons to the outside, the other opposite reaction, we know oxidation should happen in this particular electron. Okay, so we have Cl minus, and 2Cl minus can become Cl2 by losing 2 electrons, isn't it? So this is what happens in this cell. So once you supply electricity, these two reactions, these two half reactions will occur. So this is oxidation half reaction. So now we know something called anode cathode, right? So how do we link that word anode cathode to this setup? So here, what we remember from our unit 13, we have two words, anox and red cat. Remember, anox and red cat. So that means anode is where oxidation happens and cathode is where reduction happens. So here, then this reaction is our what? Cathodic reaction. Cathodic reaction. So here, cathode is negatively charged. So this is opposite from our electrochemical cell. Okay, so electrochemical cells are producing electricity. Okay, so for them, cathode was positively charged. So anyway, don't remember that. Don't memorize it. Just like we are doing here, try to work it and get the answer. So now the next reaction should be the oxidation reaction. This electrode should be our anode. Anode, or you can say it is our positive electrode. Okay, so it's simply you can say the positive one is connected to this, no? So this must be positive and this must be negative. So like that you can understand. Okay, so now let's add the two reactions and fully explain what I said earlier. I said earlier to you, we use electrolytic cells to do, we use electricity to do non-spontaneous chemical reactions. Okay, so now let's add these two and see. So in order to do that, I need to multiply this one by 2, right? And it becomes 2NaCl. We can separate the ions and write, or you can write in this way. It's no problem. Both are the same. And we'll give you 2NaCl2. Now this reaction is a gas, and this reaction is a non-spontaneous reaction, because you can see, you can understand, molten sodium chloride will not give sodium, no? So you learn in O levels, this is what happens in down cell. Okay, so extraction of sodium, remember. So this is an unspontaneous reaction. So we need to supply electricity and do this reaction. So that those are the reactions that are happening in electrolytic cells. Understood? This is what we call as electrolysis. Okay, electrolysis. Right. So now we have a good idea about this one. So we also know what are the two reactions relevant for our first example. So anode reaction is 2Cl minus 2Cl minus uh, loses 2 electrons and become Cl2. Okay, so you need to give physical states. This must be a liquid. Right. So in the same way, we can write our cathodic reaction. Sodium plus liquid gains 1 electron and become Na liquid. Okay, so now it's very simple, Lamai. So this example we can fully explain, but for the other 4 examples, right, you don't need the reason. Okay, so but in the theory class I explained to you that, but here I'm going to roughly tell you that's it. But for A levels, you don't need the reason. Just remember these 4 examples. Okay, the value is once you remember these 5 total examples, you can do those 2019 like similar questions, because you need to, when they give a electrolytic cell, you need to figure out what is happening at the anode, what is happening at the cathode, right? Like that, you need to understand that. Okay, so in order to do that, you need to remember these 5 examples. That's it. Okay, that's it. Okay, now if you go to our questions, I'm going to explain to you that. So in our question, you can see this aqueous copper sulfate is there, and you are using what are the electrodes you are using? You are using copper electrodes, right? So here, then it is kind of the same as this example. So if you remember this example, what is happening at the anode and what is happening at the cathode, you can easily write the answers for these questions. That's my point. Okay, just remember what are the anodic and cathodic reactions. That's it. Okay, so now let's come back to this one. And now let's write about the second example. Okay, in second example, a little bit explain this one. In our second example, we have aqueous sodium chloride solution. Aqueous sodium chloride solution. Okay. So now in this solution, not only sodium plus, you have H plus also. Where this H plus comes? Where this H plus comes? Because it is aqueous. So in any aqueous solution, you have some amount of H plus. Okay. And then not only these two ions, water also coming near this. We can call it now properly cathode. Okay. And so the negative ions will go to our anode. So what are the negative ions here? We have Cl minus, we have OH minus. If H plus exists, OH minus should also exist now in water. And then again, water molecule can go to both anode and cathode. Okay, so now the thing is, Lamai, there will be a competition. There will be a competition. Okay, understand it properly. There will be a competition among these 3 ions. Okay, so to do what? To undergo reduction. So the one that has the most ability to do that and the reasonable concentration for that will undergo reduction. So don't think about that much in the logic. Just understand and remember, here sodium is not going to undergo reduction because its reduction potential is low. Okay, So then here H plus can't also undergo reduction. The reason is H plus concentration is also low. So what will happen here? Here Lamai, our water will undergo reduction. So when we are writing that reaction, so once water undergo reduction, it will give you H2. So now hydrogen is balanced. So to undergo reduction, it needs two electrons. It needs two electrons, okay, because in water, hydrogen was H plus, okay, remember? Now, to balance this one, we need to add 2 OH minus, and therefore we need to add one more water. Then only the hydrogen and oxygen will be balanced. Then it will be 2 H2O liquid. Understood? This is our reduction reaction. This is our reduction reaction. Okay, H2 is produced near the cathode. And what will happen near the anode? So like that, a similar competition will be there. Now earlier, this competition was not there. Only Cl minus was present. No, but now you have Cl minus, OH minus, water, everything are there. So now there will be a competition among these three ions. Okay. So the one that is going to win here is Cl minus, Cl minus. And just go and remind the theories, Lamai, and there will be there is an influence from the concentration. Okay, if the Cl minus concentration was lower, then this will not be oxidized. Okay, then it's going to be water, the one that is oxidizing, right? So anyway, don't think about that one. You will learn this again in your industrial chemistry too, because we have this sodium chloride aqueous electrolysis in industry also, right? So I'll show you why we are learning that one. So however, remember Lamai, here Cl minus, okay, with a proper, if there is a proper sodium chloride aqueous concentration, Cl minus will undergo reduction, sorry, oxidation, just like earlier, okay, by giving two electrons. So now we know what are the two reactions that can come to this electrolytic cell reaction. So it's very similar to the earlier one. Here now it is aqueous, Cl2 gas and two electrons are given. Now here in the cathode, what is undergoing reduction is water. Okay, they take two electrons and become H2 gas and 2OH minus. Okay, 2OH minus. Okay, so now why do we learn this one in why do we learn this one in industrial? It's very simple. Now look at this one. Near the cathode, what will be remaining? OH minus will be remaining in the solution. And Lamai, sodium plus will also be remaining, right? Because sodium plus didn't reduce, no? So then what is the compound we are ultimately achieving in the solution? We can take out sodium hydroxide. So this is used in sodium hydroxide or caustic soda production. In industrial chemistry, we use this electrolysis. Understood. So just remember here what I want to show you, Lamai. When there are several entities in the solution, there will be a competition among them. Okay, so there will be one winning reaction, and that winning reaction is decided by concentration and its reduction potential and several other factors. Okay, so which you don't need to explain for the exam. Okay, just remember what are the anode and cathode reactions. That's what we need. Okay. Right, so then we have three more examples. I'll quickly tell about them too. And if you take acid diluted water, so that means you are taking, solution like dilute H2SO4. Let's take dilute H2SO4. So now near the cathode, you have H plus and water. Okay, since it is acidic, now H plus has a reasonable concentration and it will become H2. It will become H2. So 2H plus become H2 by losing two electrons. And now near the anode, you have a competition between sulfate ion, OH minus ion, and water molecule. Okay, so what is going to be winning here is again water. So now water will undergo oxidation. So what will be the reaction? H2O will undergo oxidation and become O2 gas. So during oxidation, it should lose 4 electrons because here oxygen is in -2 oxidation state. And if I put 2 here, there will be 2 oxygen. So -4 to 0, losing 4 electrons. Okay, now to balance this one, we have to consider the medium as acidic. If you consider the medium as basic llama, you will not get this reaction. Okay, so you can try it and see. So this is the reaction. This is the reaction. Okay, so this is what happens in the anode. Okay, so now if you add these two reaction, cathode reaction and anode reaction, let's multiply this one by 2 and add. Now earlier I made a small mistake here. You need to, this is reduction, no? So you need to add the electrons to the left side, right? Okay, so here 2 electrons and H2. Okay, now if I multiply this one by 2 and add to the second reaction, what will I get? What will I get if I add these two? So you can see hydrogen H plus ions will get cancelled, no? So you will get 2 water becomes O2 and 2H2. So this is what we call as electrolysis of water. Okay, so water is electrolyzed to give O2 and H2 gases in 1:2 ratio. Okay, you might have done this one in your O levels. Okay, so my point is the reactions you have to remember. Okay, Lama? Reactions you have to remember. So now what is the anodic reaction here? Anodic reaction is H2O liquid giving you, 2H2O liquid is giving you O2 gas and 4H plus, 4H plus and AQN 4 electrons. And the cathodic reaction is the reduction. 2H plus gas takes 2 electrons and become H2 gas. Okay, so like that, remember. And now we come to our A-level question topic. It's about copper sulfate. Copper sulfate. Now, I didn't that much emphasize about another word, Lama. You might have noticed that one. So all these electrodes are having, but you can see inert electrodes. Inert. What that means? So that means those electrodes are not reacting with the solution. And there is no reaction related to the electrode. So such electrodes are, we can give examples, graphite electrodes and platinum electrode. Those are called as inert electrodes. Okay, so then in the last example, we are using copper electrode. So copper is a reactive metal, somewhat reactive metal. So not like platinum or graphite. So copper will participate in the reaction. I'll show you how it is. But first, let's see what is happening in copper sulfate aqueous solution electrolysis using inert electrodes. Okay, so now let's take this is to be copper sulfate aqueous solution. So now in this cathode, you have what? The positive ones, copper 2 plus, then you have H plus, then you have water. In the anode side, you have sulfate, OH minus, and water. So now again, there is a competition. So from this competition now, copper 2 plus will win. Okay, because it has a good reduction potential. So it will reduce and become copper metal. Okay, so that means copper metal will be deposited here. Okay, from the anode side, from the competition, you remember these three ions were there in acid diluted water electrolysis. Remember in this place. So similarly, water will be the winning reaction here. So water will oxidize to O2 by losing 4 electrons. Understood? So those are the anode cathode reactions. Okay, here we are using inert electrodes like graphite or you can say platinum. Right. Now the thing is, at the same time I'll explain. Now if you use copper electrodes instead of platinum or graphite electrodes, what will happen now? Now, Lamai, let's write the reactions. Let's write the competing entities. You have copper 2 plus, you have H plus and water. So similarly, same three ions are there now. So this one will be the winning reaction. So again, copper will be deposited. Copper will be deposited. Okay, so this is your cathode reaction. Cathode reaction. But for the anode, now a special thing is happening. So those three ions are there. That's not change. But Lamai, now this is a copper electrode now. This is also a copper electrode now. So now this copper electrode is an active electrode. So copper can actively undergo oxidation. Understand? So copper would like to undergo oxidation because it's a pure copper rod. I mean, it's a copper rod, so it has more copper. So copper has the ability to undergo, oxidation here. It will undergo oxidation. Understood? So now copper oxidizing is the winning reaction. So it has to do something with the concentration and its potential. Understood, Lama? So think like that. Okay, no need the reasons behind this because it is kind of difficult to explain the reasons because there are multiple factors affecting who's winning here. So simply remember who's winning because you can apply this knowledge to those questions. Okay, so in this A-level question, you have copper, very similar example for this, no? So in the anode, copper will dissolve and cathode, copper will be deposited. That's what happens. Okay, Lama. So now we can fill the remaining two rows in our table. So here, the anode reaction, the one that is undergoing oxidation is water. See, you can see there's a pattern, right? In copper sulfate with inert electrodes, because the same reaction is repeated in several places. If you're smart enough to remember this one, then you can tackle these questions very easily. Okay, so here copper 2 plus AQ is gaining 2 electrons and becoming copper metal. The same reaction will happen when you use copper electrodes. So now this copper electrode using thing we can use for electroplating. Remember, in O levels you might use this method to plate silver on a spoon, right? So like that you can use for electroplating because one metal is dissolving and that same metal is depositing in the other electrode. Okay, so here then what will happen? Copper solid will dissolve, oxidize to become copper 2 plus aqueous. So now these are the 5 examples. So I took some time to explain you this because it is very valuable. So it'll be a quick revision, will be helpful for you before your A-level exam. Now, let's go to that question, 2019 A-level question, and discuss what is happening there. Right. So it's very important to understand the reactions, right? Understanding, remembering the examples and using those examples, we are going to find out what are the reactions happening. Okay, now let's take a minute and go through this. So now this is your negative electrode. So like I explained you earlier, here, what will happen? From negative electrode, electrons will come out to the system. Now this is the path of electrons, okay? This is the path of electrons. Now you can see this fourth electrode is gaining here, the reduction should happen. Reduction should happen, okay? And then electrons are coming above and going to the other side and here again reduction will happen. So what I'm drawing like this. This is the metal that are depositing. In the cell B, M metal should deposit. In the cell A, copper metal should deposit and then the electrons will leave the system like this. Just follow the electron flow, Lama, yeah? Follow the electron flow. Right, so now you know what happens in cell A and cell B. Cell A and cell B. Right now, so first they are asking for you to identify anodes and cathodes, right? So what about this first one? What about this first one? First one here is acting as the anode, right? Because the electrons are losing here. Yeah, so kind of coming outflow is there. Okay, so that means copper metal is dissolving here, and here copper is depositing like that. So you can say A or the 1 is our anode, and then 2 is going to be the cathode of cell A, cathode, and third one is again anode of the cell B, and fourth one is the cathode of cell B. Understood? Right. Then they ask in the reactions taking place. Now, don't accidentally write equilibrium reactions, Lamai, because this is not equilibrium. This is not equilibrium. This is actually something happening. So you need to write complete reactions for electrolysis. Okay. So now first one, in A, copper solid dissolves. So don't forget to put physical states. It's very important. Here, copper solid is dissolving. In the second electrode, copper is depositing, just like our last example we saw. Okay, just like our last example. Okay, and here, now you need to write about metal M. Now, don't panic and write M2 plus or something. It's not M2 plus. You can see carefully. It is, according to the formula, it is SO4 2 minus. So there are 3 such ions. So that means our metal M should have 3 plus charge. Metal M should have 3 plus charge. It's similar to Al2O3, remember. Al3 plus and O2 minus. Okay, it's similar to that. So here our metal charge is M3 plus. Okay, so now in anode, that metal M dissolves and becoming M3 plus AQ. It's very important to write in that way. So it loses 3 electrons. And in the cathode, M3 plus ions will take 3 electrons from the electron flow and become metal M. Okay, so these are the 4 reactions. So it's very simple. If you remember the examples, it's very simple. You can understand. And then go to the next one, third answer. Third question, they're asking calculate the constant current used in the system. Now, for that, there are some other data given in the question which we didn't pay attention. Now it's time to look at them. So here we are doing the electrolysis for 10 minutes. It's important. And it says this the cathode of cell A, which is our number 2 here. The mass of that cathode is increases by 31.75 milligrams. Okay, and again they are telling the cathode of cell B, which is the fourth one, mass is increases by this amount. Okay, so now we can use those data to calculate the current. Okay, so I'll just remind you the flow I taught you in the class. It's very simple. Okay, it's very simple. This is how you need to think. First of all, Lamai, you have the mass of copper. So then from that, go to the moles of copper. Moles of copper. So simply what you have to do there, divide the mass by molar mass of copper. But here, unfortunately, they haven't given you the molar mass of copper. Copper, let's take for the question, it is 63.5 grams per mole. Okay, so they offer marks for using symbols, okay, because they haven't given you the value. Okay, anyway, so after finding the moles of copper, your next task is finding moles of electron flown. Okay, so how do we do that one? Because take our reaction. It is saying copper 2 plus is gaining 2 electrons and becoming copper. So according to this, you can see it is 2 to 1 ratio. So if you have some moles of copper deposited, there will be twice like that electron moles. So simply what you have to do here is multiply this one by 2. Then you will get the moles of electrons flown. Okay. So then you have to go to the current. I will go to the charge. Okay, Q. So how do we find Q? That's the next problem, right? So you can find Q, charge, by multiplying these moles of electrons by Faraday constant. And another unfortunate thing for this question, Lamai, they haven't given you the Faraday constant also. So what is the Faraday constant? 96,500 coulombs per mole. So they didn't give Faraday constant in 2025 A-level question also. So in any way, good to remember. By the time you go to the exam, anyway, you will remember this. Okay? Don't worry. Right. So after finding moles of, charge of the total charge flown, okay, the total charge flown, and you can go to the current. You can go and find the current. So for that, you are using another formula. Just remember them in the sequence, okay? It will be really easy. Current is equal to Q over T. This one you might have picked from physics, right? Uh, Basically, the current is charge per unit time. Hmm? So you know the time, it is 10 minutes. So you can easily divide and find the current. So remember this flow, okay, Lamai? Remember this flow. So they can ask questions in the exam in the opposite direction also. They might give you the time and current, and then you can find the charge, then you can find the electron moles, then you can find the mass, like that. Okay, so remember this flow. It's very important. That's the next step of this question. Okay, so now let's apply that knowledge and find out our current. Okay, so first of all, moles of copper. Moles of copper. So how do we find it? 31.75 milligrams. Milligrams means 10 to the power minus 3 grams divided by 63.5 grams per mole. Okay, so if you want, you can simplify, but you can keep it. So anyway, if you simplify, it will be the answer. Here, 0.5 into 10 to the power minus 3 moles. Okay, so then you can find moles of electrons. Moles of electrons flown. So that will be twice the moles of copper. 0.5 into 10 to the power minus 3 mole into 2. So that is 1 into 10 to the power minus 3 moles. So then you can find the charge flown. Charge flown. 1 into 10 to the power minus 3 moles into 96,500 coulombs per mole. Faraday constant has a unit. Okay. And after you are simplifying, you can get 96.5 coulombs. Then you can find the current. By dividing this 96.5 coulombs by 10 minutes. 10 minutes means, if you convert to seconds, it is there are 60 seconds for 1 minute. So 600 seconds. 600 seconds. Okay. So it's simply 0.965 division 6. Okay. For 9, you have 1. Then for 36, you have 6. And for you have 5. For 5, for 50, yeah, 36. And for 5, you don't have anything. And for 50, you have 8. Okay, so 0.16 was the answer they gave. Because if you rounded it off, that will be the answer you are getting. Okay, 0.16 amperes. Is that clear, Lamai? That is the method you are doing it. Okay, now not only that, they are asking the last possible question here, the molar mass of this unknown metal M. Okay, so the relative atomic mass of metal M. Okay, so now you can understand, if you came the opposite direction, you can get the answer, but no need to come from the current, because you know from our diagram, the same moles of electrons flow around the circuit, right? So that means if 31.75 milligrams of copper is depositing at the second electrode, okay, so that means 1 into 10 to the power minus 3 moles of electrons have flown. So same number of electrons have flown through the cell B also. Understand? So you can start from there. You can start from there. So now you can say moles of electrons flown, moles of electrons flown, that is 1 into 10 to the power minus 3 moles, 1 into 10 to the power minus 3 moles. Then Lamai, you can get the reaction. So M3 plus takes 3 electrons and become M. So what's the ratio? 3 to 1 ratio. 3 to 1 ratio. So then you can show moles of M deposited, moles of M deposited. That is 1 into 10 to the power minus 3 over 3 moles. Okay, so now you know the total mass. Okay, so you know if you go to the equation simple M or capital M, you know the mass and moles. So what you don't know is the molar mass. So simply you can use this equation and find the molar mass of this equation. So molar mass is equal to what? The mass here is, let's go and see again, 147.6 milligram. 147.6 into 10 to the power minus 3 grams. And divide this one by the number of moles. 1 into 10 to the power minus 3 over 3. Okay, so 3 goes to the numerator. And it will be 147.6 into 3. So it's 8, 1, 21, 22, 12, and 14. Yes, 442.8 grams per mole. So what they're asking is the relative atomic mass. So therefore, relative atomic mass of M is going to be 442, 442.8. Is that clear, Lamai? It's not a difficult question once you understand what I said regarding the electrochemistry, electrolysis actually. Okay, so practice this question again and try to learn this until you have the ability to teach this to someone. Okay, so and you can write a good note about this electrolysis examples, so you can understand. It's all depends on how much you remember these examples. And there was another good question. We'll do it again in some other time, and I'll add a video of that too. Okay, so until then, see you, Lamai. Study well, and if you have further questions on this question, you can always reach me. I'm there to help. Okay, so then goodbye. Study well.